This video is going to introduce the basic terminology around material physics for both GCSE, and then subsequently the same information is also relevant for A-level. So when we talk about materials, this in GCSE corresponds to P2.3, or forces in action, and it relates to a section on Hooke's law. If this is A-level physics that you're looking at, then obviously this appears in Module 3 in materials. So Hooke's law and materials, and understanding what happens when we apply forces to materials, is an important topic within physics and has quite a few very predictable questions. So very often this topic will manifest in you being able to interpret a graph of the experiment of Hooke's law, which is particularly important for you to know and how to analyse. But before we get into that, it's necessary that we understand the terminology and key words around this topic. So first of all, the most important thing to understand to begin with is that when we talk about resultant forces on objects, the result of a resultant force, the outcome of a resultant force, I should say, is one of four things. A resultant force will either cause an object to accelerate, which means speed up, decelerate, slow down, change direction, or the fourth outcome is change shape. Now, we have a special term that we use for that in physics, and that is deformation. So deformation is the term that we use to refer to any object that is changing shape. Now, in order to cause an object to change shape, one of the first things you must understand is that you need two forces on an object. So let's take, for example, this example of a spring. If, in order for me to cause this spring to change shape, I have to apply two forces. If I only apply a single pulling force, you can see the object is not changing shape, it's just simply accelerating. But if I apply two tensile forces, and those are forces in opposite directions to each other, then you can see that this object will change shape, okay? In this case, it will extend, okay? And then I can remove that force in a process called unloading, and it will go back to its original shape in this case, okay? So obviously you have tensile forces, which is any two forces acting outwards on an object, but you can also have compressive forces. Okay, so to give you an example of that, if I just show you this example of science putty, okay, so I can shape this into, say for example, a ball. Okay, I apply two forces in opposite directions towards each other now. Okay, and that is two compressive forces, and you can see I've caused the object to change shape. Okay, and again, if I apply at least two forces, I will cause that to happen. So when we look at the three outcomes of deformation, or three types of changes of shape, we can cause objects to stretch. When we apply tensile forces, we can compress an object, we can squeeze them, okay, if we apply compressive forces. And then the third outcome that's also possible, which requires usually three forces, is if I apply a force at each end and then a force in the middle, I can cause objects to bend. Okay, so they can stretch, they can compress, or they can bend. Three ways that they can change shape depending on the way that I apply forces, either tensile, compressive, or bending forces. Okay, so three ways I can cause objects to change shape. Now, different types of materials will behave differently when we apply these different forces to them. So the first type of material and word I want to understand is the word elastic. So elastic just means, as you can see here with this elastic band, when I apply a force to it and I stretch it, when I then subsequently unload that force, so I remove the force, it returns to its original length. So elastic is following deformation, an object will return to its original shape. We can see that again with the spring in this case, that when I apply a force to it and release the force, it returns to its original shape. So in this case, it's behaving elastically. It returns to its original shape. That's why we call elastic bands. That's what the word means. It means you apply a force, it returns to its original shape, following unloading. Now, the opposite of elastic is the word plastic, okay? So if I take my science putty again, when I apply a force to this, I apply my crushing force, my compressive force here, and you can see now this has been permanently deformed. This hasn't gone back to the original shape that we started. Now, this material is also malleable. I can mold it into shape. So I'm going to remold this back to the original ball. Okay, so I can remold it, it's malleable, but when I apply a force, again, it behaves plastically. You can see it's not returning to a ball. Now, that would obviously be different if I'd got, say, for example, a sponge ball in my hand. I could squeeze a sponge ball and it would return to its original shape, okay? So this is behaving plastically. This is elastic. So elastic means an object will return to its original shape. Plastic is when an object is permanently deformed following unloading. And unloading is just the word we use for removing force. So we can then talk a few other words that you should be familiar with. So first of all, malleable. As we said, malleable just means an object can be moulded into shape. So I can take my science putty, I could take a piece of metal, for example, and I could squeeze it, I could bash it, I could bend it into shape and make it form more or less whatever arrangement I want. Anytime you get any material that's malleable, the reason that happens is because the molecules or layers of molecules are free to slide over one another. And that means as I apply a force to my silly putty, that then the molecules have time to move around, to change their orientation, and to form a new orientation, and hence they slide over each other. Now, the next word that we need to know is the word ductile. And ductile materials mean that they can be drawn into wires. So for example, if I apply two tensile forces on this putty, you can see I can draw this out. You can see I can keep applying my tensile forces. I'm drawing this into a wire, okay? And this is a type of plastic deformation because you can see when I unload the force, I leave it there, then it stays in that shape. So this is a type of plastic deformation. So I just want you to understand this process for a second, right? I have my putty, and initially it actually, this is a little bit difficult to see, but it does behave elastically initially. I apply a very small force, there's a little bit of spring to it, so it does return to its original shape for very small forces. But this material, this is ductile because it has a large plastic region. So if I stop removing the force here, it's permanently deformed, right? But that permanent deformation can continue and continue and can continue. It's all plastic deformation, but it's drawing it out into a wire. And so this is what we mean by ductile. So ductile means that an object can be drawn into a wire, but one of the key criteria for something to be ductile is it has to have a very large plastic region. Now, suppose the polar opposite of these two things is brittle. And brittle is when, following the application of a force, a material fractures very suddenly, it breaks very suddenly, and there's no plastic region. So I can make the silly putty behave in a brittle way if I apply a sudden force to it. So now, instead of it being drawn out into a wire, it's going to break very, very suddenly, and we're going to see it fracture, and what we should see is a clean, sharp edge. So I'm just going to position it and then apply the force quickly. So because this is warmed up, this is now quite malleable, so let's try again, if not. So that's too warm. Okay, let me just try with a different piece of putty because I've been using that too much in my hands now. So, true Blue Peter style, here's another one we prepared earlier. So if I apply a force to this quickly now, there we go. All right, I managed to get it to break. So you can see this is fractured instead of being drawn into a wire. Again, let's just try this. So again, a quick force, and you can see that it's sheared, fractured, when on that sudden application of force. So this is what we mean by brittle. An object can break. And obviously powders and certain rocks, for example, are often brittle. They break suddenly upon the application of force. So these are all the sort of basic key terms that we need to know about materials. There are one or two others, but we're going to apply those in the context of a graph of materials. So at this point, make sure that you are familiar with all this terminology, and in the next video we'll focus on how we relate these things to actually the title of this, which is Hooke's law. So we need these terminology first, and then we can apply it to our graph in a moment.